Hi everyone, I'm Pallav from Just Tutors and today we will learn about the structure of carbon compounds and functional groups. So we are going to learn about functional group today. In organic chemistry we have few functional group like alcohol group, ketonic group, aldehyde group and some other groups. We are going to learn about that. While functional groups are the group of specific group of atoms which gives a particular property or specific properties to the hydrocarbons here. So before we move further and learn about functional groups, I want you to try these questions. You can pause the video, try these, and then we'll move on. Well, I hope you got the correct answers, and now let's move on. So, what are the functional groups and how are they formed? Well, carbon is a very friendly element. So, other than hydrogen, it can also react with halogen, nitrogen, and sulfur, oxygen as well. So, what happens when any of these elements has to react with hydrocarbon? The one of the hydrogen is replaced by these atoms, and these atoms are called heteroatoms. Well, these are replaced in such a way that the valency of carbon remains satisfied. So we have one example here, like here we have methane, in which we have four oxygens bonded with carbon, but now we have some foreign element, or we can say heteroatom, which reacted by replacing one of the hydrogen atom here. Heteroatoms also come in the groups, and that groups are called functional groups. For example, we have alcoholic group in which we have OH, oxygen and hydrogen. So we have few more groups. We will talk about that in the session. And these functional group represent a specific properties. The functional group gives specific properties to the carbon compounds, no matter how long the chain is. These are some functional groups like halogroups. Halogroups means halogen. It is made up of halogen like chlorine and bromine here. Heteroatoms are chlorine and bromine. Then we have other groups alcohol, aldehyde, ketone, carboxylic acid, ester, in which the heteroatom is oxygen, and then we have groups amino nitro in which heteroatoms is nitrogen. These are the suffix, like how do we pronounce the name after the carbon compounds are bonded with these functional groups. So we will talk about that as well in maybe the next video. So now let's move on. First group is halo group. Here the heteroatoms, as we discussed, is chlorine and bromine. One example is here CS3Cl, chloromethane. So we can see that how does it form actually? So we can see that we have four hydrogen atoms in methane, and one hydrogen is replaced by chlorine. So if we talk about properties, the haloalkanes have the melting and the boiling points higher than the alkanes. When I say haloalkane, it means it is the general name for all the alkanes which have halo groups attached with them, and then they are soluble in organic solvents but less soluble in water. And then we have the order of bond length and bond strength according to the groups, according to the halogens we are using. Now let's move on. Then we have alcoholic group. As the name suggests, alcohol, it is used in beverages. It is soluble in water. It can form hydrogen bonds and used in beverages and antifreezes. So you can see here, this is the hydrocarbon group and this is the alcoholic group here. So one good example is ethanol. We have it is made up of ethane. When we know that the ethane has the formula of C2H6, one of the hydrogen is replaced by the alcohol group, and thus we have ethanol. Now let's move on. Then we have aldehyde group. It is formed by oxidizing alcohol. So the formula you can see here, we have aldehyde here. Here we have the hydrocarbon chain, and it is hydrocarbon chain, and this is the bond with which the aldehyde is attached here. One good example is methanol, like CS3CHO. Well, I'm sorry, that is CH2O, methanol CH2O. Here you can see that the one carbon is here in the center. So we can say it's a carbonyl center, carbon having double bond with oxygen here and one bond with hydrogen. So methanol is used as a germicide, fungicide, preservatives. These aldehydes are soluble in water and volatile and have pungent smell. And then we have ketone group. In this we don't have hydrogen. We have C double bond O. So ketones are produced while the body burns fat for energy, and also produced when body don't have enough insulin, and used mainly in solvents. Solvents are like in which the solutes, in which the substances get dissolved. One more important thing, that ketone group is attached in the middle of the carbon chain, and the group at the both the sides of ketone can either be of same or different. So here one example of acetone, here we have CH3 both the sides of this ketone group. So we can say CH3COCH3, and this is a general structure in which the both the sides we have different groups. Now we have carboxylic acid. Well, important part of the kitchen. So acetic acid or vinegar we have used or we see in our kitchen. So it has the carboxyl group COOH. It is an organic acid and polar in nature. When we say polar, polar means the which does not have balanced electric charge, and they have strong odors. Well, this was all about these functional groups. Now let's move on. So we have some questions. You can pause the video, try these questions, and then we'll check the answers. Well, these are the answers of given questions. I hope you got the correct answers again. Now, thanks for watching this video. For more, you can visit justtutors.com. Thank you.